its form, the jackal proud and tight. In search of you, I feel my way through the slowest evening night.
Well, hello, John, and thank you very much for agreeing to do this Geo-Legends interview. We were talking earlier on and saying how important it is for young engineers to have an idea how somebody very successful develops their career, and I think both of us agree that's kind of where we want to go with this. And I think we're not going to give an overview of your whole career as a kickoff, but rather the story will develop as you answer the questions. Yes. Are you happy to go with that?
I'm happy with that, yes. Yes. So, I can give a bit of early background, but which might help.
Okay, so do you want to start?
Yes, yes. I was born in England in 1936.
Wow.
Which ages me. In the county of Buckinghamshire. And I went to a primary school there. And then in 1948, my parents emigrated to South Africa.
Okay.
And they put me into a little Afrikaans school for a year as a primary school, where I learnt to speak Afrikaans fluently.
Wow.
And I still have some.
Okay.
I can still recite in Afrikaans, but
okay.
I won't do it now. Then I went to a public school in Johannesburg for 5 years, a very good one actually. Had a very good grounding in Latin and French and mathematics. And after that, I went to the University of the Witwatersrand,
okay,
which is in central Johannesburg, for 4 years, and read a degree in civil engineering.
And do you remember why you decided to go down the path of studying civil engineering? Or?
I think it was because C is at the top of the alphabet, actually. But it was a choice between that and architecture, to be honest. Okay. Both at the top of the alphabet.
Okay.
But there was nothing. I don't know why I chose civil engineering, but it's in the dim and distant part. But I'm really glad I did.
Okay, that's good. That's good.
So that was 4 years as an undergraduate, and I got quite excited by the prospect of doing some research, because the professor of geotechnical engineering and the head of department there was looking for a research assistant for a year. He got some research money, and he asked me if I'd be willing to join him for a year as a research assistant, and then perhaps do an MSc after that. And I liked that idea, although I wasn't very good at saw mechanics at that time. He wasn't a very good teacher, actually. I found it difficult to follow. I really did at that time. So I acted as a research assistant to him for a year, really on earth pressures against retaining walls, or earth pressures against reservoir walls, actually, which was an issue, because there are a lot of reservoirs and dams in South Africa, because water supply is a very important topic there. And while I was doing that work, I had the opportunity to read very deeply in soil mechanics, and I completely absorbed the work of Tizadi and Peck, and got very excited by it, actually. And originally I was going to do an MSc in hydraulics, but I decided to stay with soil mechanics. So I did an MSc for a year, mainly by research, and studied unsaturated soils. That was the area that I worked in. And it was fairly controversial work, because I concluded, as a result of it, that the application of the effective stress principle in its very simple terms, that is, a single effective stress variable controlling behaviour, quite clearly had limitations in unsaturated soils. And for years after that, I used to be confronted by people who said, "You must be a crank. How can you possibly, argue against the effective stress principle?" But I think it's widely accepted now that you can't just use one stress variable when you're dealing with unsaturated soils. You have to include the suction and the total stress separately. So although that was very controversial at the time, I think it's now widely accepted. So that was really the outcome of my MSc at Witwatersrand University.
And that led to some very highly cited papers.
It
At least
did.
one.
Yes.
But still,
Yes.
I still see it
A
referred
paper
to very often.
paper with Jennings.
Yes, exactly.
Limitations of the use of the effective stress in
Exactly.
unsaturated soils. Yes, it was definitely seminal.
And that's unusual for someone at MSc level to manage to deliver research that ends up having such an impact on the profession.
Yes, no, it's very gratifying, actually. It really is.
That on its own, apart from anything else, is a big achievement.
It's a good start. Yes. So that was really my start in South Africa.
And did you ever consider staying to do a PhD in South Africa, or?
Well, I mean, I ought to give you some of the background to South Africa because, again, this is somewhat controversial. But we arrived in South Africa in 1948, and it was exactly at the time that the Nationalist Party was voted in.
Okay.
And although there was a kind of apartheid, but it was more social than legal.
Okay.
And what the Nationalist Party did was in 1948, they passed a law which is called the Bantu Education Act of 1948. And that made it illegal to educate an African beyond Standard 8, which is below matric level, actually. And the argument when one looks at the way that law was passed and phrased was that Africans weren't capable of doing anything other than working as servants and labourers, and we should be training them to do that.
So just to kind of be clear, that matric level would be kind of the end of secondary school, and
it would be.
They were not even allowed to go
that was far. The entrance to university, basically. It's what was over there called the matric.
Yeah.
So that was the theory of it. I mean, I look back on it and read the reasoning behind that law. I just say, well, go and tell that to Mandela and Bishop Tutu and see what they've done. Does the argument just falls flat on its face. But the thing was that Wits really held out against the apartheid legislation. It was one of the few centres that did.
And that's the area where you lived?
And that's the area in Johannesburg, Witwatersrand University.
Okay.
And that university really was a beacon.
Okay.
And it just did not obey those particular requirements. And at that time, I was a student leader, and I felt very strongly about the apartheid laws. And I spent quite a lot of time in Soweto, a nearby African township, tutoring African students to get their matriculation or the equivalent of their matriculation examiners, often by external exams, Oxford and Cambridge and so on, to enable them to get entry into the university.
Okay.
So I was stopped on one or two occasions by the police, and they knew all about me, and I was informed that what I was doing was illegal, and that I would be, they would make sure that I, was attacked in some way and made to pay for breaking the law. And at that particular time, I was actually quite keen to get back to the UK, back to my roots. And I decided that with that threat hanging over me, I'd done my bit, and it was perhaps time to come back to the UK.
Okay.
But it was a difficult period of time, and I admire immensely those people who held out against the ghastly apartheid laws at the time. Now, what I think people don't realise is that they were entrenched in law. It wasn't just, it's not right for the races to mix. This was legally enshrined that it was illegal to educate an African beyond its present level. It's horrific, to be honest.
Yeah.
Absolutely horrific. Anyway, in 1961, I did return to the UK, and I worked for 2 years with a firm of consulting engineers, very well-known firm. At that time, they were called Arup and Partners, and they did some wonderful work worldwide. I mean, amongst other structures that they built and designed with the Sydney Opera House.
Yeah.
So they were very well known for that. And I had a very formative 2 years in practice working with them, and mainly on geotechnical subjects, although when I was interviewed in Johannesburg, I was told that I would never do soil mechanics again because Arabs were structural engineers at the time. Anyway, when I arrived in London, it turned out that they had a very deep excavation in London, and they looked around for somebody who knew something about geotechnics. I got fingered, and that was the project that I worked on.
So I was wondering, when I was thinking about this interview, how you actually managed to get that position in Arab. So you contacted them through their South African office initially?
Yes.
Okay.
The chief, or the head partner of the South African office was a South African called Jack Zuntz, now, or the late Sir Jack Zuntz. He was a brilliant engineer, and he was summoned really to head up the partnership in London.
Okay.
And he interviewed me and said, well, come and join us. Come and join us in London.
Okay.
So that's how it happened.
Okay. So kind of you didn't have to arrive in London with your suitcases and walk the streets looking for a job.
I was actually given the job before I was. That was, again, one of these serendipity things that worked wonderfully well.
Good.
So that's where I started practice there. And from there I went to Cambridge, but that's another story.
But how did you decide to go to Cambridge? Was that something that you actively decided, I'm enjoying working in industry, but I want something more and I'm going to look for a PhD? Or again, was it something serendipitous where you met someone and a conversation snowballed into you moving to Cambridge?
I mean, I'd always been very, very interested in research. And I'd kept up. I'd found the Cambridge work really interesting, although I didn't understand it at the time. Mm-hmm. They were clearly onto something new. And
by this you mean the work they were doing in terms of developing constitutive models?
That's right, yes. And very much, when I did my MSc, I spent a lot of time studying Vorschlev and Rendulic.
Okay.
Basically the Cambridge work is built around Vorschlev and Rendulic.
Okay.
And that's what interested me. So I went up to Cambridge actually with a friend and met Roscoe, who was head of soil mechanics.
Yeah.
And they basically said, you're welcome to come and do a PhD with us. And in fact, Roscoe actually found me some money to do it.
Yeah, that was the next thing I was going to ask, because that's the big battle that all our students have now is getting funding. But he was able to.
He was able to, yes. Gave me a student grant, and so I went up to Cambridge, and that's where I started working on the Cambridge models.
Yeah. So you went with the specific goal to work on that area. Sometimes people arrive and they explore different things,
yes.
But you went from the get-go to look at this.
Yeah. It was at the time of the Cam-Clay model, the original Cam-Clay model. They just developed it. I didn't really understand it at the time, but it seemed to me that it followed on from Vorschlev and Rendulic, and it was a very, very important bit of fundamental work. Mm-hmm. And Roscoe was very happy for me to work on it. Not so happy a bit later on when I decided that there were limitations to the CAM-claim model.
And is that when you proposed modified CAM?
That's right. And it wasn't widely accepted. You can imagine it wasn't grabbed with open arms at the time. But what worried me about the CAM-claim model was that it had a yield locus which came into the isotropic axis at an angle.
Yes.
And the implications of that are that if you apply an isotropic stress change,
yes,
it should show distortion.
Okay.
And that's contrary to isotropy.
Yeah.
So I thought, this can't be right. And so, I worked away on it for a long time, but eventually decided that it would be better to try an elliptical yield locus. And I got that idea from looking at Hill's plasticity work, his book on plasticity. And there, it was full of elliptical yield loci.
Okay.
And I thought, well, let's try an elliptical one, and it worked.
Okay.
And eventually, because I think Roscoe was asked to publish a paper in the proceedings of a plasticity conference that we held in about 1966.
Mm-hmm.
He went through the draft of my PhD thesis and decided that there was a paper there.
Okay.
And that's where it got the name Modified CAM-claim Model.
Okay.
Upset some people, but it wasn't an easy time. You had to fight your battles in Cambridge.
Okay.
And that's where it came from. It was basically this idea that it just didn't seem to me right that you should get distortion under a change of isotropic stress for something that is defined as an isotropic material.
So looking back on that and having to, as I say, really defend your ideas, what do you think that brings to a PhD? Is it an opportunity for growth in terms of helping you develop the ability to be resilient and to articulate your ideas, or is it something that made you feel maybe more undermined? Because I always think we have to strike that balance between challenging people,
yes,
and then there's a point where maybe we need to hold back sometimes in order to let them reflect on that and not lose their confidence.
Well, I can tell you that working, I had the distinction of working with some very difficult supervisors, and Roscoe was one of the more difficult ones. And you had to fight your corner. There's no doubt about that with Roscoe. You had to justify your ideas. And it took a long time. There were times when I was very despondent.
Okay.
You have to, it's a challenging atmosphere. And quite rightly too. He really did challenge. And that's what a university is all about, isn't it? So it's character building. And we had to learn to fight our corner and rigorously argue our case.
Yeah, and that's what comes to mind as you're saying that. That's going to lead to rigorous science in the end. Rigorous science.
Yes. Yeah. I think that's what Cambridge was all about, to be honest. It's character forming.
And so, at the end of your time in Cambridge, you moved to the Building Research Establishment,
yes,
the BRE. Yes. And I think, I'm conscious that we're doing this with the ASCE. And I think for me, in terms of drawing an analogy, it's almost like in a national laboratory, but with a focus on infrastructure. Would that be kind of a good way to describe it?
There's quite a history, actually. This is BRE, Building Research Establishment.
Yes.
It was originally the Building Research Station, and it was at that time it was a laboratory which was part of the Department of Scientific and Construction Research, the Department of Science and Scientific Research and Construction. So it was funded by government to do research, and the research agenda was, obviously it had to be rigorously vetted, but by and large it was developed by advisors and the staff at the Building Research Establishment itself. And that worked very well. And it was science funded by a grant from government through a government department, but it was run by scientists and by engineers, and that worked very well. Halfway through my stay, and that I did some very, very interesting work there, which I doubt would be funded nowadays. For example, a lot of work on deep excavations, which started when I was at O'Varrett's, but we continued it. And I was involved in the design of the underground car park at the Palace of Westminster, and that started at BRE.
Yep.
That started because of the work that I was doing there. And there was a huge amount of fundamental work that I did on the chalk in East Anglia, where there was a proposal to build a nuclear accelerator in the chalk. And we did some fantastic work, large-scale testing, which is still seminal, really. And that was the kind of work you could do at that time. Then some years after I went there, the government adopted a different approach to research. It was called the customer contractor principle, introduced by Lord Rothschild, the Rothschild principle, who said that any work funded by government had to have a customer, which sounds very simple, but customers aren't research-minded, and life became much, much more difficult trying to get anything more than kind of ad hoc research that was going to please the latest Secretary of State for Environment or whatever it was on his pet subject. And to be honest, that was the reason why I left. So at the time that I joined there, it was wonderful. It was a scientific research establishment. But later on, it really became very much more of a commercial, and has now become a commercial testing establishment and research establishment.
Yeah, I was going to ask you, what facilities did you have there? Was it for element testing, or were you doing physical model testing?
We had a superb laboratory, and of course that's where soil mechanics almost began in the UK with Cooling and Golder and people like that. They were at the building research station, and that's where basically Cooling was the father of soil mechanics. So it was one of the very first places that soil mechanics started, and Skempton went there. That's where he started, and then moved on to Imperial College.
So did you work with Professor Skempton? Did your times in the BRE?
Not at BRE, but of course very much so when I came to Imperial College.
And we're sitting in the lab, in one of our labs in Imperial right now, and that was a very nice idea of yours to actually bring this interview.
Oh, it has to be in the lab, doesn't it?
So, and we're surrounded by two ring shear apparatus, which we can't move. They're very heavy, and in the background there's a hollow cylinder apparatus. There's many triaxial cells, and that goes on into a second research lab. But obviously you played a role in developing the facilities here. But you came, Professor Skempton and Professor Bishop had developed some facilities here, and then, is that why you chose to come to Imperial, or how? I mean, because there are other very good universities in the UK.
Basically, I was asked to apply, but because Bishop was not well and was due to retire, and clearly they wanted to replace him, and I was asked to apply, which I was very happy to do, to be honest, and honoured to do.
And so you transitioned here. This is in the mid-80s when you came to Imperial College.
Yes.
And then when you came, you then obviously you'd already been working in research, but the kind of new string to your bow that you really had to develop then was teaching.
Yes.
Do you want to say a little bit about your philosophy of teaching and how you found that challenge? Because you were very established in your career. You were probably juggling many balls.
I did actually come up to Imperial 2 or 3 times a year
Okay.
to talk to the students or give them a lecture or two about the modified campaign model.
Okay.
So I knew the people here very well.
Right.
And basically, it's true to say that they invited me. They said, "No, John, do apply."
Okay.
And I was honoured and very pleased to.
And when you were teaching here, your teaching focused entirely on soil mechanics, geotechnical engineering.
Yeah. Yes.
At undergraduate and postgraduate, taught postgraduate.
Yes. Absolutely. I was appointed as Professor of Soil Mechanics, and so that was my subject, and it was a huge honour to be given that job. And that's when I started the teaching, which I love, actually. I really do. I love it.
The first time I came across your name was in my very first soil mechanics lecture, where our lecturer, Dr. Creed, gave us the paper that you wrote about what is geotechnical engineering and teaching of geotechnical engineering. I think it was the Nash lecture in the International Conference.
It was the Nash lecture. Yes.
And do you want to maybe say 1 or 2 words about that idea of linking the different elements together?
I mean, I didn't find teaching easy, and I did find that the students got very confused about the various aspects of soil mechanics. What was theory, what was empirical, what was as a result of testing and so on. It can get muddled very quickly because there are a lot of aspects to geotechnics. And I felt that this was my opportunity to really try and sort it out. And so in preparing the Nash lecture, I eventually, and I think I read quite a lot of articles on how to teach and how to structure subjects and so on. And it seemed to me it was impossible, it was essential to try and highlight a number of very key aspects of geotechnics. And the 4, I developed the soil mechanics triangle, or the geotechnical triangle, as we now call it, which has, right at the top, it has the geology, the origin, and the genesis of and what is there and how it got there. And that's absolutely fundamental, absolutely fundamental. And then another key aspect of geotechnics is measurement and observation, experimental work. And that's a discipline in its own right. I mean, this is where Bishop developed his whole career around testing, and that's absolutely vital. And then the third key aspect is modelling, either theoretically or physically, even intuitively. But it is a very important part of the whole quantifying, really, what is happening. And the fourth aspect, which lies right at the centre of the geotechnical triangle, is empiricism and experience. And I found in my practice that I'd ask where so-and-so came from my experience. And so I developed the phrase, well-winnowed experience. It's got to be experience which is relevant to the particular problem we're talking about.
Okay, I was always wondering what you meant by that term, well-winnowed.
Well, I'll tell you where it came from. It was Tazagi, who spent 2 years collecting a vast amount of data. And I think he relates how he then took it to his office and began to sift through it all. And he said most of it was chaff.
Right.
And I thought, chaff, winnowing, getting the grain from the coating of the grains.
Nice.
And I thought, well, this is what we're doing. You can't just say from experience, is it relevant? And that's what I meant by well-winnowed experience.
Very clever. Very nice. And then in your teaching, you have developed some models.
Yes.
And did you develop them for undergraduate teaching, or I mean, I know you did a lot of outreach work as well. Who were the initial audience for these models?
Undergraduates, really, and to help myself. But yes, I mean, I find that a good model is never forgotten.
Yeah.
An equation is, but a really good model makes a huge, huge impact.
Yeah.
And so I did try and get into my lectures illustrative models which would not be forgotten.
Okay.
I want to show the importance of water pressure between contact points of two grains, because they're fundamental to soil behaviour. And I'm going to do that using two beakers, which will be resting on a sloping frictional surface. The first thing I want to do is to make sure that the surface is a bit damp, so that the mechanism I'll be demonstrating isn't just thought to be lubrication, but friction. So let's make that a damp surface. And I'm going to put on the top of it, this sloping surface, a beaker. Here we are. And you'll see that that beaker is stable. Of course, if you increase the slope of this surface, it'll become less stable. But at present, it's stable, full of water. Now let's take an identical beaker. Here we are. And pour water into it. And remember, it's on a already damp surface. And we'll see what happens.
Good thing there was no computer over there.
Absolutely. So it's unstable. You can see what happened. Now, why is that? Well, the reason why is that there's a hole in the bottom of this beaker. So the pressure in the beaker is transmitted through this hole to the cavity just beneath the beaker. So a water pressure builds up between the rough surface, the frictional surface, and the base of the beaker. And that therefore reduces the contact force between the beaker and the frictional surface. And when you do that, you reduce its frictional resistance, because resistance is a function of normal stress and shear stress. And what you're doing is you're keeping the normal stress the same, but reducing the contact stress by means of a water pressure. So that very simple little demonstration really encapsulates the whole of the effective stress principle. The water pressure is just as important as total pressure in the behaviour of granular materials, frictional granular materials.
And so when you were teaching undergraduate and MSc students, you would bring this in?
A model can be used for anybody. That is the power of a model. I think people don't forget that in a hurry.
No.
So I think it's a very powerful and very simple demonstration.
Wow, no, it's lovely. I actually haven't seen this one before, I don't think. Very, very nice.
Okay, now the purpose of this model, or these models, is to demonstrate the concept of the stability of a tower on the ground. So here is one. It's on rock, or very hard surface, and it's obviously stable. And if we give it a perturbation, it comes back. That means it's stable. The definition of stability is, if you give it a perturbation, will it recover? So clearly, that tower is stable. Now I want to build a tower on very soft ground, which represents the situation at Pisa, There's a strong belief that the reason why it's leaning is that it's approaching a bearing capacity failure. And actually, that's not the mechanism of behaviour of the Pisa Tower. I want to show you now what the behaviour actually is. So let's build this tower step by step.
And that's on a sponge, John? So.
It's on a sponge, it's on foam rubber. So it's a compressible foundation. Now at that height, it's stable because I can give it a perturbation and it comes back. So let's go a bit higher. And it's still stable, and it still comes back, but it's struggling a bit. Now it really is very marginal. It just about comes back. It's very nearly in what we call neutral equilibrium. And one more brick, and it's now about to fall over. There it goes. So now what's the mechanism there? It's clearly not bearing capacity, because there's been no failure here. It's all to do with the compressibility of the foundation and the dimensions and weight of the structure. And the phenomenon is actually very similar to the buckling of a strut. In fact, the equations are almost identical. And it's to do with the fact that once it starts to lean a little bit, it generates an overturning moment, some pressure on the foundation here, and there comes a time when, in fact, the overturning moment generated by this small perturbation is larger than the resisting moment that can be developed in this elastic foundation, compressible foundation. So that is the phenomenon of leaning instability. And our measurements that have been made on the tower for the last 100 years or more give exactly that form of movement. It's not a bearing capacity failure at all. It's leaning instability. And that was a major step forward in developing our stabilization measures, identifying this leaning instability phenomenon. Okay.
So when I was an undergraduate in the 1990s, and that's probably true of other people of my age, that the Pisa project had a high profile.
Yes.
And there was a video that we were shown in our soil mechanics lecture that included images of you walking on a beach in Italy.
Yes.
Yes. And, you know, that's...
It's called Propping Up Pisa.
Exactly. It's on Netflix now, or it was a couple of months ago anyway, which I thought was quite exciting. So I watched it again. And maybe you could talk a little about how you got involved in that project.
Yes, I can tell you, I'll never forget actually how I got involved. I had a phone call from a good friend of mine, Michaela Jamalkowski, one morning. And I sort of put on my best Italian accent and said, Michaela, it's lovely to hear from you. And he said, well, I'm not sure that you'll be too happy about this, but Andreotti, who was at that time president of Italy, or Prime Minister probably, has set up a commission to stabilise the Tower of Pisa. And I said, Michaela, I'm so sorry. That's a poison chalice. I'm so sorry. He said, John, keep your sympathy for yourself. Your name is on the list as well. And that's the first I heard of it.
Okay.
That I've been asked to join the commission to save the Leaning Tower of Pisa.
And were you working mostly then with Italian engineers, or were there other international experts on the panel?
There were 14 on the commission. There were 4, I think I'm right in saying 4 overseas experts, and Jerry Leonard's was one of them.
Yes.
And the rest were Italian.
Okay.
Yes. Carlo Vigiani was one of my brothers. Yes.
And
it was multidisciplinary.
okay. So there was so there were 14, but they were not all geotechnical.
We had geotechnical, we had structural, we had conservation experts, we had people experts in masonry and so on. So it was a wide-ranging, multidisciplinary commission.
And it was at least a decade you were working on that project?
I think it went from 1992, I think that's the date that I got the phone call. Might have been a bit before that, to about 2002. It's about 10 years.
Okay.
10 years of my life.
So was it really, how did it work? Were you having to deliver technical reports to the Italian government at intervals, or, was it more a question of we investigate, we wait and see, or, given the fact that it was a commission decreed by the government, what were the kind of constraints you were working under?
Well, we were answerable to the Italian government, there's no doubt about that, or the relevant department. I can't remember the name of it, but basically, initially, we had to decide on what action should be taken. And subsequent to that, having developed various solutions to do with conservation of the masonry, stabilising the tower itself, foundations, and other structural features, and conservation work, it was then put out to tender, and an Italian contractor was appointed to carry out the work. But we as a commission were still involved, overseeing that work. So we still met. But at the time, for about 5 years at least, we probably met 12 times a year, once a month.
They were in-person meetings, I presume?
In-person meetings, in Pisa mostly.
Okay.
In Pisa itself.
And
looking at the tower.
And was there an airport in Pisa? Was it a bit of a trek?
Oh, no, there's an international airport in Pisa. Yes.
And so there was two kind of, as my understanding, there's two key steps in that project. And one was when you put on the lead counterweights, and the second was the soil extraction. Both of those were big construction on a very delicate building. And how did you feel when, I know that these things have been really carefully thought through. I know you did some physical model testing here and some numerical analysis that David Potts was involved in. But, the day they started to put the lead on, or the day they started the soil extraction, do they stand out in your memory?
Well, yes. Yeah, they were very, very tense. But in a way, I think it's important to look at what was going on beforehand, because why did we arrive at these solutions? And the really big step was or the big task initially was to try and work through the 50 or so solutions that had been proposed in the past, because we weren't the first commission.
Yeah.
It must have been about the 14th, I should think. And there were lots of other papers published at the time as to what the solution should be. And certainly my reaction at that time was, let's first try and understand what the mechanism of behaviour is. And that's absolutely key, because there were so many different theories. For years, everybody attributed the lean to a bearing capacity failure. Fortunately, from the turn of the 20th century onwards, beautiful measurements have been made on the tower. And a very, very careful study of those measurements of the movements showed that it couldn't possibly have been a bearing capacity failure. And I came to the conclusion that it was a phenomenon which I can demonstrate with a model later on.
Yeah.
We'll show that in the model. That it's what we call leaning instability, which is all to do with the compressibility of the ground. And that's a very different problem from a bearing capacity failure or other mechanisms of movement. So it was absolutely vital to understand that mechanism first before we started our various solutions. And basically, we came to the conclusion that it was this phenomenon of leaning instability, and that a way of dealing with it was to reduce the inclination and to increase the diameter of the foundations. Because leaning instability is very much a function of the diameter of the foundations. But we first of all had to stop the movement and, if possible, reverse it. So the lead weight solution, that you wouldn't have dreamt of using if it was a bearing capacity problem, was basically to try and bring the tower back a little bit and to slow down the movement. And then the under excavation work was to bring the tower back quite a lot. And that was then followed up by increasing the diameter of the foundations.
And so in all of that, there's a group of 14 of you, all of whom are very, very established engineers. You have the Italian engineers, who the Italian education system is very good. They have a very strong theoretical basis. And you were coming in and having these discussions, and were there very robust arguments?
Very.
How did you come to that
very
consensus?
Robust. Very robust. That's where training at Cambridge is so important.
That's what I was wondering. Yeah. And were you using models in those discussions, or was it more drawing things on pieces of paper? How did you communicate as a group?
Well, quite early on, I involved David Potts, and we began to model it using ICFEP,
Yes.
which is a lovely program.
Mm-hmm.
And we were able to reproduce the history of inclination using that model. And they were very convinced by that. But that was a pretty important step to demonstrate that.
So when I teach computer programming, that's the case history I use at the very beginning of teaching programming, because it's the way you communicated in your Rankine lecture, or Dave Potts. The data in the Rankine lectures allows you, it's in Dave's Rankine lecture I think I've been using, it allows you to tell students very clearly a story about validation of a model and gaining towards acceptance.
That's right, yes.
So that was a crucial step.
Absolutely crucial.
Dave's work.
Absolutely crucial. We wouldn't have gone ahead with what we did without having modelled it and convinced ourselves that that it was reproducing the right mechanism of behaviour, and it was.
Okay. And so once they could see these data, you were able to bring the other members of the commission with you.
Yes. It wasn't an easy ride.
I can imagine.
It was very tough going. But,
and so were you communicating all the time in English, or did you have to have translation?
We had simultaneous translation.
Oh my goodness. So that in itself was a slight barrier to communication?
Yes, it wasn't easy. There were we had some quite amusing translations. I'm trying to remember some of them, but
I picture something like the UN where you all had headsets. And,
yes, well, that's indeed what it was. We had headsets and we had simultaneous translation.
Okay. So, but you then have used that work in a very interesting way in terms of doing an enormous amount of outreach. So communicating the story of the project to different, you came, when I was involved in Engineers Ireland in London, you presented to us. You've been very generous in terms of presenting to our undergraduate students. But I think groups who have a tenuous link to engineering, you've also gone out and...
Yes. There was another project which I was involved in and started it before I got involved with Pisa, which was the problem of the construction of the Jubilee Line extension, where I was involved as an expert witness. And there we drew very heavily on the work that Peter Rose and I did on allowable building distortions.
Yes.
and the Jubilee Line extension runs past the Houses of Parliament, and in particular the Big Ben clock tower, and now the Queen Elizabeth Tower, as it's called, and that in itself is of huge public interest. So there are really two towers in my life. One is Pisa, and the other is the Big Ben clock tower. So I do give a lecture, and I still do, and it is popular, basically called The Tale of Two Towers. And this is where you can talk to lay people. Mm-hmm. You don't have to get tremendously detailed about the technology, but you can tell the story and make it, bring home, I think, to the important role that civil engineers play in society and in conservation and so on. So that, and those two examples have been extraordinarily useful in getting across to the public the sort of work that a civil engineer would become involved in.
And I think, I mean, not everyone takes on that kind of mission of getting the achievements of civil engineering out into broader society, but it's very important. And I think particularly in the UK at the moment, there's been a lot of negative comments about infrastructure given the cost overruns in some of our projects. Absolutely. So I mean, I would imagine that your efforts in terms of talking to a broad remit of people help understand the challenges involved in delivering these big projects.
Well, I hope so. I mean, I think it is important. I mean, I can understand the frustrations that arise out of the huge interference that you get from major construction work. HS2 certainly caused me huge problems about a month ago when I was up north. Diversions and all the rest of it. But so I can understand the frustrations, but good infrastructure is actually vital.
Yes. But your work in infrastructure has not just been in Europe. You've worked in Hong Kong quite a bit. Yes. And what are the projects in Hong Kong that you've been involved in?
Initially, I was involved because they had huge slope stability problems. Failure of San Ping failure, I think, where a landslip caused a huge number of fatalities. Okay. And I was brought in by the Geotechnical Control Office, which was set up over there, actually because of the slope failures. So I was involved as a consultant to them for many years on slope stability. And then later, there have been a huge number of major works, underground railways in particular, which I've been involved in, and more recently the third runway, the new runway at Hong Kong Airport, which involves a huge amount of reclamation. So there are a number of projects out there that I have been involved in.
And what has your role been there? Have you been working for the government in terms of overseeing the projects, or are you working for contractors or consultants as an advisor? Or does it
mainly through consultants. Okay. Mainly, yeah.
And is there a different working culture in Hong Kong then compared to UK, Italy, or is it similar to London?
I mean, I don't know the details of the contracts.
No, but I mean, when you're there, when you're communicating with people,
I find them very well informed, and it's a pleasure to work out there. Yeah, very appreciative.
We get quite a few MSc students from Hong Kong.
We do.
So it's always really nice to have them in our classes.
Yes, the DICs after their names.
Exactly, and but we often get engineers from Hong Kong with some experience, and it brings a lot to our postgraduate teaching.
And for many years, the GEO out there did send at least one student a year, if not more.
Yes, I'm not sure at the moment how our students are funded. I'm not sure, but I know we appreciate them. Yeah. So one of the things that, again, maybe differentiates you from other geotechnical engineers is the fact that you've always had a close contact with structural engineering, maybe more than the average geotechnical engineer. Yes. And you gave the gold medal address in the Institute of Structural Engineers. And you may be the only geotechnical engineer to do that, are you?
It was, I think I may well be. Yes, it was interaction between geotechnical and structural engineers, which I've always found fascinating. And they are very different disciplines. I found myself quite often working with, and of course, Ovaris initially primarily structural, so I came in that atmosphere, but I kind of found myself working with structural engineers who say, look, just cut out the nonsense, just give me the spring constants, and then I can solve it. And this helped me with the Nash lecture too. This is where I found the geotechnical triangle incredibly valuable. And the analogy that I find best to try and describe to a structural engineer what geotechnics is about is to say, I want you to think about how you would tackle an existing ancient building that you have to do some work on. And in fact, there's a very, very close match. In fact, I've extended the geotechnical triangle to that aspect of structural engineering, because you have to, rather like the soil mechanics triangle, you have to find out what's there and how it got there and what it's made of for the start. You're not specifying your materials, which so often the structural engineer is. It's there. Then you've got to understand how it's behaving. So you've got to make measurements, find out, whether it's moving and how it's moving. And then there is a huge amount of experience and empiricism involved. And that's at the center of the triangle. And at the bottom right-hand corner, there's analysis. So I've been able to map out a triangle which is almost identical to the geotechnical triangle, to show a structural engineer that that's what we do is what you would be doing if you were working on an ancient building that you had to do a lot of repair work or changing it in some way. And that's why we're different from you.
Okay.
So the emphasis is not so much on analysis, which it is very much in structural engineering. It's much more in these aspects of what's there, how did it get there, what's its behaviour, experience, and so on. So that's what I found very helpful in talking to structural engineers, to get across to them what we're doing and why it's not so easy as just putting a spring constant in.
And I think listening to you, I'm wondering, is that something we need to think about more when we're teaching undergraduates? Because all of those structural engineers, I would imagine, will have taken an undergraduate class in soil mechanics.
Yes.
And how is that a failing? I mean, I do a lot of undergraduate teaching. Is that something that we need to kind of sit down and think a bit more about?
I think I'm not sure at undergraduate level. Certainly at MSc level, I think it's important. Because, at undergraduate level, soil mechanics is really one tiny subject, and it's very basic indeed. I think the odd lecture is useful. That's where I think that sort of thing is helpful, to get somebody in to talk about their experience on a practical geotechnical problem. But I think it's really the master's level that this needs to be.
And then the problem is someone does a master's in structural engineering or master's in geotechnical engineering, and they don't necessarily have common courses.
No, that's true.
I mean, the other thing that I found with undergraduate teaching is the minute you mention offshore wind or thermal piles,
yes,
they get very excited.
Very excited, yes.
But to get them to a point where you could, set a tutorial problem or a project on those topics is impossible because, you have a limited space in the curriculum. And I find that frustrating because you're trying to hook them into a career in geotechnics, but the hooks are maybe, quite high up, and it's, it's difficult.
Yeah. I think so much depends on what they do after they graduate. because I mean you can't teach them to be, fully professional engineers at undergraduate level. It's very basic, and it's rigorous thinking and that kind of thing. It's really, I mean, I find that at MSc level, I find you can pick out someone who's had a year or two in practice straight away.
Yes. Straight away.
It's working in that practical environment that is vital. I've always, perhaps this is sacrilege, but I've always emphasised, or tried to emphasise how valuable it is to do a year or two in practice before you do the MSc. I know that's not good for our numbers, but...
well, I think, the practicality is it's when people have the opportunity to move and they have constraints on how they can get funding in their personal lives.
Indeed.
But, I think that's what I really like about teaching at MSc level. And I think, I've been teaching at MSc level for nearly 20 years, and you start to get more confident. And now, one thing I really like to do is to identify at the very beginning who's been in industry,
yes.
and ask them to give presentations about their
Absolutely.
projects. And we're lucky
Yes.
we're in a position to do that.
Yes.
But,
Yeah.
as you say, maybe,
Yeah.
And I guess when you started teaching, more of the students had experience before they came to the MSc, or was it always
I think they did, to be honest. Yes, that's right.
And obviously we've talked about undergraduate teaching, your research, your consultancy, but you've supervised some very notable geotechnical engineers as a PhD supervisor, and maybe you might like to say some words about your approach to PhD supervision and how that aspect of your professional career, what satisfaction you got from this.
I have a lot of satisfaction, but I think there are two phrases that come to mind. One is regular meetings, if possible once a week, with the supervisor. And the second is encouragement. And those are two vital aspects of PhD supervision. Those would be my two watchwords: regular meetings and encouragement.
Okay. And how did you manage maybe people who came up with ideas that you could see were maybe not fully formed or not hitting the right track? Did you let them develop them for a while and then, or did you try to convince them earlier on?
No, I think that comes out in your regular weekly meeting. I hesitate to say, no, what a ridiculous idea right at the start, and say, well, have you thought about this? Let's, explore this a bit further. Would you really be able to do this, do you think? I think it's all about regular and encourage them, and if necessary, a touch on the tiller.
Okay.
Say, why not try this instead?
But I don't think you've had any PhD students of your own for quite a few years now.
No.
But you have been very involved in our PhD program by being an internal examiner.
Absolutely. Yes.
As far as I know, you're doing 1 or 2 a year, I would say, even still.
Not for a while.
Not for a while.
Not
But you
for
were
a year
doing them
or
up
two.
to
Yes.
2 or 3 years ago.
Yes, indeed.
And how do you find that coming in as an examiner to look at a body of work that someone spent 3 or 4 years of their life?
Oh, I love it. I love it. I love going through it with them. Yes.
And then
getting them to, explain.
And then your approach to the viva, the interview at the end of the PhD. Do you like to kind of push them into a place where they're a bit uncomfortable to test them, or do you feel it's better to, try to keep?
I'd never want to make them feel uncomfortable, but I would ask them to explain.
Yeah.
The last thing I'd want to do is to destroy someone's confidence.
Yeah.
But I think you can extend people. You can, I want a bit more on this. Have you thought about such and such?
Yeah.
What about?
Yeah, and I think in the British system where we have a closed viva, it's almost easier to challenge someone and to help them, because I think even in the process of the viva they can develop their ability to answer questions.
Yes.
I don't know if you've ever done PhD exams in Europe in front of an audience. Or...
No, I haven't.
Okay.
No.
That's quite a different experience.
Very different.
So and it's to do with the, as we've already talked about, working in different cultures. And then one thing that struck me when you said that Professor Yamakasi called you up to work on Pisa, how did you get to know him? Was it through the International Society or just being at similar
At
conferences?
conferences, basically.
But you have been very involved in the British Geotechnical Association,
Yes.
which is the UK's equivalent to the Geo-Institute and the Institution of Civil Engineers. And you've given an enormous amount of time to both. Last week, it was last Wednesday, wasn't it? I'm losing track of my weeks. Yes. You gave a talk to the
to
British,
the BGA.
And that was incredibly well received.
That was, the underpinning of Winchester Cathedral. Yes.
And even people here today were talking about
heroic or horrific.
How fantastic your presentation was. So you're still putting effort in and time to the British Geotechnical Association. And I mean, maybe you could just say a couple of words about, the value of these professional bodies, both geotechnical.
I think they're absolutely vital because that's where you meet people and that's where you interact. Now, I've always been incredibly supportive of the professional societies and the Institution of Civil Engineers. The one thing that I've avoided, because it's not my scene at all, is taking on the chairmanship or whatever it is of the institution. I'm not presidential material.
But you were vice president.
I was vice president,
which is a lot
some
of
years.
graft, I think.
A lot of graft, and very enjoyable. Okay. But I just don't want the presidency. Thank you. I'm not that sort of person.
I mean, the thing that, again, thinking about undergraduate teaching, that I found really useful over the past few years is the BGA Manual of Geotechnical Engineering. Now, I know you did not aim that at undergraduates, but the way it's written is so clear. I find it is a really good reference signpost. And maybe you could talk a bit about how you got involved in that and what the overall vision was for that manual.
I think the overall vision was to produce a manual which would to some extent be educational, but also useful, even as an aide-memoire to practitioners working in the geotechnical area. It certainly wasn't developed as an educational.
Yes, I understand that.
Book. It was a practical manual of experience, and I've been delighted with the fact that the readership has been so high, and that they've produced now a second edition, which involved actually more work than the first edition, to be honest.
And so were you involved in editing, or it was a couple of chapters you wrote?
No, I was a major editor, yes.
So even for the second edition, were you going through every chapter?
Absolutely.
Wow.
I read every single chapter of 99 chapters, yes.
I don't know that I've ever physically seen it, because I tend to access the online version, and it's
a very quick 2-volume manual.
Wow. And that just came out?
It's just recently been published, yes. In the last couple of months.
That's fantastic. It's a very, very big achievement. So
no, I think it's a very, very useful document. I really do. There's a huge amount of experience gone into it from something like 99 authors, I think.
Wow.
That's not that many, but a huge number.
And most of them are based in the UK?
Most of them, yes. Not all of them, most of them.
Yeah, I know that Eric Farrell did the chapter in Pete.
Indeed.
That's the only one that comes to mind straight away. And now there's some events around it going forward or it's out there and that's.
I think it's out there. I've not been invited to.
I have to say, I'm sure I'm keeping on top of what's going on with the BGA.
I think with the first edition, I do remember giving 1 or 2 talks about it, and I've not been asked to do anything on it.
And so the talk you gave last week was very much linked into the young geotechnical engineers group in the BGA.
This is the Winchester one.
Yes, the one you gave with Tim Chapman. There was a series of you here.
That was a different one. Yes.
There's a series of talks I think happening,
Yes.
and that's the one that people have been talking to me about right on the corridor this morning, saying that
that's
it was
where I
amazing.
told them about the geotechnical trial.
Yeah,
Yes,
and that's where.
Yes, that's the young geotechnical engineer
Yes.
group, which I'm so enthusiastic about. It's so important.
Yes.
Yeah.
Yes, and yeah, I mean, it's really important to get people involved in the profession, enable them to grow and see technical challenges. So we're at the time of talking, we're I think about just under 2 weeks away from the 2024 Rankine Lecture,
Yes.
and you gave your Rankine Lecture.
Gosh, when was it?
I can't remember.
1995, was it? Something like that.
Quite a while ago.
I can't remember.
And was that kind of the biggest of those lecture events that you remember? I mean, was, it's held
Yes,
in London,
be.
you're based here.
Yes.
Is that what
Yes, that was probably the biggest one I've done. Yes.
And how long did you spend preparing for it then?
6 months.
Wow.
And in fact, the section were very kind to me. They said, you'll let off lectures for a term while you write it. I'll get ready for it.
And so did you write the paper before as you were getting ready for the lecture, or did you do that afterwards?
No, I wrote the paper after, and I put the material together.
Beforehand. That's the way most people approach it. Yes, because I'm really looking forward to hearing Lydia's.
Lydia, absolutely.
It's quite exciting that someone
Very
here is
delighted that it's come back here.
that lecture again.
Yeah.
But I think we've kind of covered most of what we thought would be relevant to this interview. I don't know if you have anything closing that you'd like to say about anything.
No, I think we've covered most things. But it's a wonderful subject. It's a wonderful subject in its full entirety, and it's so relevant to society and society's development and their needs. So it's a privilege to have worked in that area. Well, I suppose it's civil engineer first, and then geotechnics second.
But thank you so much, because you've been very generous in terms of describing your professional career, and it's not it's not always that easy to talk about.
I'm honoured. I'm grateful.
And hopefully some of the people listening to this will give them some confidence about how to make decisions and develop their career and some of the issues going forward. So thank you very much.
Real pleasure, Catherine. Thank you.
Come talk to me.